Okay, so we're looking at question 2 of the solving graphically exercise from my iMaths, all about solving simultaneous equations using not algebra but using graphs. So these come in pairs. So the first question, we've got to find an x and a y that works in both of these equations. The second question, we've got to find an x and y that works in both of these equations together. And the third question, we've got to find an x and a y that works in both of these equations together. So I'm going to do that by drawing their graphs. I could do it with algebra and multiplying equations up and eliminating variables, but this exercise does ask us to do it with graphs, so we will do it with graphs. So the first one, 2x plus 3y equals 12. I'm just going to write that down on my pad. 2x plus 3y equals 12, and 3x plus y equals 11. So I've got to find a value of x and y that works in both of those. I'm going to go to my pad now. Okay, so we want to do this by drawing the lines that represent the two equations. So I'm going to look at the first equation first. 2x plus 3y equals 12. So I can draw the line of that, and it's important that you watch the first video of question 1 of this to get the background to this. I can draw the line of that by thinking about what happens when x is 0 and what happens when y is 0. So when x is 0 in this, then the 2x bit just disappears and you get 3y equals 12. So if 3y is 12, y would have to be 4 to balance that. So when x is 0, y equals 4. So that gives us a point on the graph, 0, 4. When x is 0, y is 4. Now I'm going to think in the first equation about what happens when y is 0. So in the first equation, if y is 0, then that middle bit disappears and you're left with just 2x equals 12. 2x equals 12, so x would have to be 6 to make that balance. So when x is 6, y is 0, that gives us the point 6, 0, and then we've got 2 points where the line crosses the axes. So now that we've got those 2 points, we can join them up, and then we get the straight line that represents the equation 2x plus 3y equals 12. Now we've got to do 3x plus y equals 11. Well, if I think about what happens when x equals 0, then I'm just left with y equals 11. So when x is 0, y is 11, so it goes through the point 0, 11 like that. Now I'm going to think about what happens when y is 0. So when y equals 0, we get 3x equals 11. So x would have to be 11 divided by 3, which is 3 2/3. So it goes through the x-axis at the point 3 2/3, 0. When y is 0, x has to be 3 2/3 to make that balance. So if we join those up, we get the line that represents the equation 3x plus y equals 11, and then where they meet up in the middle should give us the solution to their simultaneous equations. So this point where they meet in the middle tells us what x and what y value work in both equations. So we can see that they go through the point 3, 2, which means that x is 3 and y equals 2. So x equals 3 and y equals 2 give us values that work in both of these equations. I can check that with by putting the values in. So if x is 3 and y equals 2, 2x plus 3y becomes 6 plus x, which is 12. And then 3x plus y becomes 9 plus 2, which is 11. So it does work, so I can confidently fill that in on the iMaths. So I fill in 3 and 2, and then I can go on to the next question, which says, just writing this down on my pad as I speak, 4x plus 3y equals 15, and x minus 2y equals 12. So I'll go over to my pad now, and here I am. So the first equation, 4x plus 3y equals 15. I'm going to think about drawing a line that represents that, and doing that by figuring out what happens when x or y are 0. So when x is 0, the x bit disappears and you get 3y equals 15. So y would have to be 5 to make that balance, so it goes through the point 0, 5. Now again in the first equation I'm going to think about what happens when y is 0. So if y was 0, that bit in the middle would disappear and we just have 4x equals 15. So x would have to be 3.75 to make that balance. So it goes through the point, a little bit hard to draw on this scale, it goes through the point 3.75, 0. So if I join those two up, then I get a line that represents the equation 4x plus 3y equals 15. Now I've got to be careful here, doing it with this thick pen. I'm see that? I'm likely to go a bit off somewhere. So on yours, try and do it with a sharp pencil and maybe on a bigger scale to get it more accurate. I have to use the big thick black pen really for the benefit of it being visible on a video, but hopefully you'll see the basic idea behind this, even if my graph goes slightly askew. Okay, let's draw the second one. So x minus 2y equals 12. So I'm going to think about what happens when x is 0. Then you just get minus 2y equals 12. So y would have to be minus 6 to make that balance. So that's a point on the graph down here. When x is 0, y is minus 6. Now I'm going to think about what happens if y is 0. Then the middle bit just disappears and we just get x equals 12. So when y is 0, x has to be 12 to make it balance. So those are my 2 points on the axes, and if I join them up, so they appear to meet down here at the point 6 minus 3. So if my graph is accurate enough, x equals 6 and y equals minus 3 should give me two values that work in both equations. Well, let's just check that out. So 4x plus 3y would be 24 minus 9, which is 15, so that's good. And x minus 2y would be 6 minus minus 6, which is the same as 6 plus 6, which would be 12. So that is right, 6 and minus 3 do work, so we can confidently fill that in on the iMaths. So I'll just fill in 6 and minus 3 on there, and then go on to the next question. I will just, as I talk, write this down on my pad. So here it is on my pad. The first equation, x plus 4y equals 14. So if x was 0, then 4y equals 14. The x bit would disappear. 4y equals 14. So y would have to be 3.5 to make that balance. So when x equals 0, y equals 3.5, giving us a point at 0, 3.5. Still in the first equation, if y was 0, then you just get x equals 14 and the y bit would disappear. So that gives us a point 14, 0. When x is 14, y equals 0 makes the first equation balance. So having got those 2 points, I can join them up, and that gives me a straight line that represents the equation x plus 4y equals 14. Now let's look at the other equation. 3x plus 2y equals minus 3. So I'm going to think about what would happen if x was 0. If x was 0, that bit would disappear and we'd just have 2y equals minus 3. So y would have to be minus 1.5 to make that balance. So when x is 0, y has to be minus 1.5, which gives us a point down there at 0 minus 1.5. Now I'm going to think about what happens if y is 0. So if y is 0, the middle bit disappears and we get 3x is minus 3. So divide everything by 3. X would have to be minus 1 to make that balance. So when when y equals 0, x has to be minus 1 to make that balance. So in fact, the 2 points that make our straight line are pretty horribly close together actually, and we've got to join them up carefully to get the solution to our equation. I'm just carefully trying to get that in the right place. So just about there. So it appears to meet at the point minus 4.5. So minus 4 back horizontally and 4.5 because it's 4.5 up vertically. So it looks like where our graphs meet, x equals minus 4, y equals 4.5 gives us the solution. Now, to be honest, I double checked that with the algebra and I've edited it out of the video just because my graph with that thick pen will be possibly a little bit inaccurate, but it does check out, and obviously you can make your graphs a lot more accurate with a better pen than I've got. So minus 4 and 4.5 are the values I'm going to fill in on iMaths. Minus 4 and 4.5, in they go. Let's mark it. Hooray, 18 out of 18.